In the US, the American Cancer Society just came out with a very sobering report that uh, statistics are such that now the leading cause of cancer death in people younger than 50 among men is colon cancer.
The leading cause of cancer death for men under 50 is now colon cancer.
And by 2030, they estimate that it will become the leading cause of cancer death for both men and women. So that's a real change from where we were, 10, 20 years ago.
And I feel like that is a long way from the common conception, because you're actually saying that as a cause of death, for example, that would actually be higher than breast cancer for women under 50 in just a few years. Is that correct? Did I understand that?
Exactly. Yeah.
Which I feel is, and it obviously in no way reduces the seriousness of breast cancer or any other cancer, but it does suggest that there is not a popular understanding of just how common this is becoming as a cancer for younger people.
Correct. Yeah. I mean, I think that's another trend that we're seeing. We're also seeing that, for example, breast cancer incidence is rising also in younger women, not at quite the rate of increase as we're seeing with colon cancer. So cancers in general seem to be shifting downward in terms of when the age at which they're starting to first present, but the increases are the most striking for cancers of the gastrointestinal tract.
So, Andy, I have to ask, what's going on?
Well, that's the big question in the field. I think there's been a lot of obvious interest in trying to understand why this trend is occurring, because only by understanding why it's occurring can we actually start to figure out how to reverse the trend. So there have been a number of hypotheses and a number of risk factors that have been characterized based on the studies that we have underway now. This is a research area that my group is particularly interested in, and I think what we've wanted to focus in on are things that we know are risk factors for colon cancer more broadly, to see if they might be playing a particular role in younger adults. First and foremost in that has been, I think the trends that we've seen population-wide, at least in the US and also most other countries, in the rising incidence of overweight and obesity. Those are risk factors for colon cancer in older adults. So it's not surprising that they also turn out to be important risk factors for colon cancer in younger people. And we all know that obesity and overweight have been rising as well in the population over the last several decades. So some of that increase in cancer rates might also be attributable to some of those increases we're seeing in overweight and obesity. So that's one factor that we know is important. The second area that we are really interested in knowing more about is the role of diet. I think that our diet has changed appreciably over the last several decades in many ways, as you probably can glean from sort of how we think about diet and with respect to overweight and obesity. Some of those same dietary factors may be driving colon cancer rates as well. We know people, for example, eat more concentrated sweets, they eat more meat, and those are risk factors that we know also are risk factors for colon cancer. So some of those population trends and those dietary factors may be also driving risk in younger people. There might be also some unique components of food that we're still really delving more deeply into. We know that our diets now, as compared to 10, 20 years ago, are much higher in what we call ultra-processed foods. So foods that are designed to be highly palatable, easy to eat, have a lot of convenience built into them, are foods that have been really increased in consumption over the last several decades. And ultra-processed foods have been linked to cancer rates as well. The other area that's also of interest for people is the changes in the way we consume alcohol. Alcohol, particularly heavy alcohol use, is a risk factor for colon cancer, and we know drinking habits have changed a lot again over the last several decades, even preceding the pandemic. So that has been something that we've been studying in a more intensive way. And then some of the things that are particularly interesting also is to think about some of the overlooked dimensions of these risk factors. I think we think about these as being risk factors, but also need to think about, when during the life course are these risk factors most important? Is it the fact that people are, really maybe eating more of these unhealthy foods at an earlier point in their life cycle, like, when they're adolescents or young adults, than in past years that may be driving risk in a different way? We also know there are dimensions about when we eat food and when we drink, which is important. So, for example, we tend to drink more now in large quantities. It's so-called binge drinking. So, is binge drinking a particular risk factor for cancer in a way that more consistent low-level drinking was not? These are all kind of really important dimensions of exposures and risk factors that we're considering. And then last, I think we all recognize that there are many people that are younger than 50 that develop colon cancer that don't have any of these risk factors. I have many patients that come to me that are lean. They've never been overweight. They eat a very healthy diet. They don't consume large amounts of meat. They really watch what they eat, yet still get the disease. So those are not. This is not a complete explanation for why we're seeing the trends. There's other things out there that are driving risk that really are at this point speculative. I think we need to investigate further. Are there environmental factors, pollutants, things like that have still been not characterized that we need to maybe investigate further? We recognize that cancer is a disease ultimately of metabolic health, especially colon cancer. We think colon cancer in particular is a cancer that's driven by someone's overall state of metabolic health. And among cancers, we think colon cancer is probably the cancer that is the most likely to be related to diet and what we eat, which is not surprising because obviously the colon is exposed to what we eat.
Could you just explain for a minute what a disease of metabolic health means for our listeners?
Sure. So just to back up, I mean, I think our interest in this came around because we recognize that as you sort of tick through the different cancers and sort of what are the cancers for which diet is the most likely to be linked, colon cancer is probably the leading cancer that's diet related. We also know that colon cancer is particularly related to other factors that we associated with how we metabolize food and our metabolism more broadly. What I mean by that is there's been a lot of interest in, for example, the fact that, again, people with overweight, obesity are more likely to develop colon cancer. People with diabetes have a higher risk of colon cancer. People who have so-called metabolic syndrome or a constellation of sort of conditions related to what we call insulin resistance are more likely to develop colon cancer. And insulin itself has been thought to be a risk factor for colon cancer. That high levels of insulin in the blood, for example, drive the uncontrolled growth of cells in the colon. And so is, for example, the sort of high levels of insulin that occur and related to metabolic diseases a driver of colon cancer. I think that's been really a leading hypothesis too. So I think of the cancers of the body, colon cancer is the one that seems to be most linked to metabolism, or how we eat our food, how our body processes food, and our body's response to food.
I think you're saying that you might increase your risk of colon cancer, not just directly because the food you eat is sort of directly like this carcinogen, like we're all used to being taught by, our governments over the last 50 years, but actually, if you're eating this, ultra processed food or whatever it is year after year, then you get all of this bad control over your blood sugars and your blood fats and all these sorts of things. And that itself then becomes this risk factor for the colon cancer. Did I understand
Precisely.
that?
Yeah, no, that's a very good way to summarize it. That there might be some specific effect that the food we eat is having on cancer, but also we know that the food we eat affects exactly what you've mentioned. It affects our overall level of inflammation in the body. It affects our overall metabolic ability to metabolize and process food, and sort of our metabolic biochemical functions may be changed. We may have less ability to control our blood sugar. to control our blood lipids. So the fact that diet can, for example, raise our blood sugar, raise our insulin levels, raise our inflammatory markers, also raise some of the other lipid markers that we know may cause, again, inflammation or diseases in our blood vessels, may also be causing problems with our ability to prevent our colon from growing tumors and developing cancer.
And Andy, I'm sitting there looking at the beautiful view in your office behind you as you say that. And it reminds me of the first time that I met you, which must be 7 years ago, I think now, when I was with my co-founder, Professor Tim Spector, and talk about this idea of kicking off this very first Predict1 study, looking at the impact of diet, but particularly about sort of the microbiome and how that tied into diet and different personalized results, and rather amazed to discover how interested you were, which is, when you started working with us now a long time ago. So I would love to discuss, because I know this is a big part of your personal research and interest, how the gut microbiome sort of links into the things that you're describing, to what extent you believe that the health of your microbiome, is linked to, your risk of developing colon cancer, and I guess what the status is of your research and others around that today, because I know that this has been a big part of why, you've been, really interested to and helped us a lot in the research we've been doing.
Yeah, so as you mentioned, it's been a terrific history we've shared together and working together on the ZOE Predict studies here at Mass General. And our interest, I think, was driven largely because we are so interested in diet and the gut microbiome and what its impact is on health in general. So just as we really recognize that diet was a major sort of risk factor or element of colon cancer risk. In parallel, we also recognize that there was increasing data that the gut microbiome was an important factor in the development of colorectal cancer. There have been and there have continued to be a large number of experimental and animal studies that show that the gut microbiome is linked to colon cancer in a very direct way. So you can induce cancers by changing, for example, a mouse or an animal's microbiome, and you can reverse cancer by changing an animal's microbiome in a positive way. So that data is really, really compelling. That shows that linkage between gut microbiome and cancer in these experimental models.
Andy, just before you move on, I just want to make sure that I got that right, because there's often a debate about the microbiome and to what extent it has any real cause rather than just being an indicator. But here you're saying that in animals, they've literally been able to, you put the sort of the wrong bugs in and you can get this cancer, and equally well, if you change them for the better bugs, you can actually prevent the cancer?
Exactly right. Yeah. So, I mean, there's cause and effect that we can show in experimental models in animals. That I think has been very compelling. At the same time, we are seeing increasing data in humans that the gut microbiome is an important risk factor. There have been a large number of epidemiological studies that have shown, for example, that people who develop colon cancer have a different gut microbiome compared to people that do not. And those changes in the gut microbiome are changes that are similar to the changes that you see in mice that develop cancer, more directly. So, there's very strong kind of convergence of that human data with the mouse data that suggests that what we're seeing in experiments are likely to be very relevant to the human condition. I think there's also, a large number of studies that have shown that people who have what we call a disrupted gut microbiome or have disruption in gut microbiome have a higher risk of colon cancer. So in particular, there are several studies that have shown that people who are exposed to large amounts of antibiotics, particularly when they're younger, which we know is almost like a nuclear weapon against your gut microbiome, that those people have higher rates of cancer and colon cancer down the road as well. And I think now there is also more information about the presence of gut microbes actually in the colon tumors themselves. So when you actually look at the colon cancers that develop in people and actually do very targeted experiments where you can try to identify if there are particular gut microbes in those tumors, they're identifying some of these bacteria that we know cause cancer in animals. So I think there's really compelling data that what we're seeing as cause and effect in animals is likely to be causal in humans as well.